All right, to do the graphing waves, you're going to have the Excel sheet open as well, or the Google sheet open. And so it'll look like this when you start. And what you need to do is you need to just plug in these numbers here into the corresponding locations. This final column, you're just adding these two together, right? So 0 plus 0 equals 0. 0.8 plus 2 equals 2.8. 1.5 plus 0 equals 1.5. 2.2 minus 2 equals 0.2. Okay, so you're just going to do that all the way down for all those 30 data points. When you do that, these graphs will start to populate on their own. So you'll want to make some observations about this graph for wave 1 and the graph for wave 2. And then look at what happens when we put those two together. Okay? So you'll need to answer these questions here. So that is how to do the graphing waves. Okay. In measuring waves, we're going to measure the wavelength, which is an equivalent point and the next equivalent point on a wave. So we could do crest to crest, trough to trough, or rest position to rest position. This group of waves here is called a wave train. A single wave is called a cycle. The distance between the rest position and the crest, or the rest position and the trough, is called amplitude. Frequency is the number of waves that pass per second. So we're going to assume each wave train on this paper takes 1 second. So we're going to take our little ruler, and you're able to pick it up and move it around. So this first one says, how many waves are there in this train? So we want to count. A wave goes all the way up and all the way down. So that's 1, 2, 3, 4, 5. So we would say that there are 5 waves. So let's figure out the wavelength. So I'm going to grab my little ruler. I'm going to go to the crest on one and the crest on the other, and I see, oh look, it's about 2.7. To calculate the amplitude, I need to rotate my ruler 90 degrees. So I hit this little arrow rotate button. And that's going to flip it 90 degrees. So now I can move it and put the 0 on the rest position. And I see the amplitude is about 1.2. Okay. I want to make sure I get this back to where it needs to be, so I just hit the rotate guy 3 more times. So it's now right side up. Frequency is the number of waves that pass per second. So we're assuming this entire wave train takes 1 second. So if there were 5 waves in this 1 second, its frequency would be 5. Wave speed is just wavelength times frequency. So 2.7 times 5. So 13.5. Okay. So you'll do the same thing for all of them. All right, there's another ruler here. Number 7 says, if this entire wave train is 30 meters long, what's the wavelength of just one wave? So we have to figure out how many waves are there. Well, it looks like there are 6. So if these 6 waves are 30 meters, that means each individual wave must be 5 meters in length. Once you finish determining the length and the frequency and amplitude and speed, you can check here. And the values are here for you to check. So this is how to complete the Measuring Waves review page. All right, so this is just a review of Chapter 9. Amplitude is the energy of the wave. Sound waves are longitudinal waves because they have compressions. And you can tell that if you put your hand in front of your mouth, you can feel little puffs of air when you talk. Part 3, or number 3, says to draw a transverse wave on a string and label all the parts. So just do the best you can. So we're going to draw a transverse wave, right, up and down. And we're going to have, there's our rest position. So we're going to say this is the amplitude. And we're going to say from here to here. That's the wavelength. That's going to be the crest. And down here is going to be the trough. Okay. Next, we want to draw what a spring would look like, a longitudinal wave. So on a longitudinal wave, we've got spaces where they kind of spread out, and then they get in tight together, and then they spread out, and then they're tight together. So we would say that where it's spread out, that's the rarefaction. Where it's tight together, that's the compression. And then from one point to the next point, that's the wavelength. Okay, frequency. The number of waves that pass a point in a unit of time. That unit is hertz. Wavelength, the length of a wave, its unit is meter. From a transverse wave, you can measure crest to crest or trough to trough. For a longitudinal wave, you would say from compression to compression, or rarefaction to rarefaction. Okay, number 9 says, what's the wavelength of a sound wave with a frequency of 50 hertz? The speed of sound is 342 meters per second. So we know speed of sound. We know the frequency. We need the wavelength. Okay. Well, wave speed is wavelength times frequency. So we're going to divide both sides by 50. And we see our wavelength is 6.84 meters. Okay, number 10 says, a sound wave in a steel rail has a frequency of 620 hertz and a wavelength of 10.5 meters. What's the speed of sound in the steel rail? So we know wavelength, 620 meters. We know frequency. Oh, sorry, that's frequency. So, all right, so the frequency is 620 hertz. The wavelength was 10.5. And we're trying to calculate speed. Again, speed is wavelength times frequency. Right? So sound traveling through air travels at 342 meters per second, but traveling through steel travels at 6,510 meters per second. So that's quite a difference, right? Sound travels a lot faster in solid materials. Okay. Number 11 says, if a wave is traveling at 60 centimeters per second and has a wavelength of 15 seconds, what is the frequency? So we have speed, and we have wavelength. Trying to find frequency. Solve for F. Frequency is 4 hertz. And the last one says, calculate the speed of a wave that has a frequency of 5 hertz and a wavelength of 10 meters. Just multiply the two, the wave speed is going to be 50. So the speed of sound, like all waves, depends upon the medium through which it travels. Sound travels faster in solids and slowest in gases. Number 14 says, we see a bolt of lightning, and 4 seconds later we hear the thunderclap. So the speed of sound is 342 meters per second. How far away is the lightning? So speed is 342 meters per second. We know our time is 4 seconds. Trying to calculate distance. Remember that speed is distance over time. Solve for D. So 1,368 meters, which is almost a mile away. All right, so number 15 says, how many seconds will it take to an echo to reach your ears if you yell toward a mountain 82 meters away when the speed of sound is 342 meters per second? So I like to draw this one. So here you are. La la la. Here's a mountain, and it's 82 meters away. And so you yell, no, and it hits and bounces back. And it takes 4 seconds for you, so it travels 82 meters away. And so we want to figure out how long will it take the echo to reach your ears. Okay? So we know that our speed is 342 meters per second. The distance traveled to get to the mountain is 82 meters, but then it has to travel back to you. That's another 82 meters, right? Because it has to go there and back. So the total is going to be 164 meters. 164 meters because it has to go all the way there and all the way back. So we want to calculate our time. Remember that speed is distance divided by time. All right, can't have a variable in the denominator, so I got to move it out. And now I can divide both sides. So it should take about half a second. Okay, in the next part, we're just going to match the terms with their definitions. All right, so the highest point on a transverse wave, that's the crest. The area in the longitudinal wave where the particles are close together, compression. The ability to move or change an object, or what a wave carries, energy. A wave that is caused when energy vibrates through a medium. This is a mechanical wave. The type of wave, or mechanical wave, in which the energy runs at right angles. Transverse. Type of wave in which the energy is parallel, so side to side. So this is a longitudinal wave. The lowest point on the transverse wave is called the trough. The area where particles are spread out is called the rarefaction. The material through which a wave travels is called the medium. And then the length of one wave to the next is called wavelength. And so that is the waves review page.